Justin's going to give us a demonstration on the CNC mill on how to do a circular interpolation using the intuitive programming that our mill has. The part that we're working on right now is for a BattleBot, and what we're going to be doing is we're going to be machining this hole right here that is to a 1.12 diameter. We cut out the blank on our water jet machine and we roughed the holes in. So what we're going to do is we're going to go in and make a finish pass on there with an end mill. So the first thing Justin's going to do is he's going to go in to the MDI mode, and we have to set up some parameters here by pushing the program conversion button. He's going to come in to where he can set up his tools, his work, things like that. So right now what he's going to do is he's going to set up his end mill. And you can see right now we're using a, I don't know how clear it's going to be, 695 diameter end mill. We're using a high-speed steel end mill. And you can adjust the diameter settings and stuff under the tool tab on here. So once we know that that's correct, he's going to hit escape, go into the work tab that's at the bottom. And under that we can select our work 0 offset, and we can also select the type of material we're working with, which is aluminum. And that's going to enable the speeds and feeds. So now he's going to get out of there. He's going to go back up to the top, the tab's at the top, and he's going to go over to where we have pocket milling. He's going to select that, and under pocket milling he is going to select circular. And under circular he needs to set up parameters. It shows where the 0 part on our part is actually set. We're not center drilling anything. We're using tool number 1, which is an end mill. Where it says the hole depth, he's going to select the depth that he has to go. We're using 3/8 thick material, so he's going to put a depth in there, how deep he wants to go. And he's going to go 1/2 inch deep, so he'll put 0.500 in there. G54 is our work offset. Our R-plane, we're going to stay 200 thousandths above the part. The X and Y locations, he is going to put in the locations we have here. We have a minus 7.88 from the edge, and we're going to be 620 thousandths up from the bottom in our Y, so he's going to plug those numbers in. He's also going to come over here to the diameter of the hole. The diameter was a 1.12 diameter, so he needs to change that. Once he has all of that information set, he's going to output this to an MDI program. So if he selects F4, it asks him, what do you want to output it to? We're just going to output it to MDI because we're going to delete this program then after we're done. And when he does, it creates the G code that is necessary to machine this hole. So now that we have this set up, Justin's going to go ahead and shut the doors here, and we're going to run the part, and you're going to be able to see the machine come down and do our hole. Kind of tough to see with all the coolant, but whenever we're done, now we have a machine surface. We're going to check it with our telescope gauges and make sure we're on the right size. If we need to, we can offset our wear in our tool column and machine that a little bit bigger if we need to take some more stock off. But that is how we use circular interpolation and the intuitive programming system to machine a hole.